Hello, I am Sudhakar. Today we have a hands-on session on drum brake assembly, especially on S-cam type drum brake assembly. This is a typical axle that are used in a heavy commercial truck. Today we are going to dismantle the entire brake assembly and identify its component and operation and assemble it back. During assembly, we would appreciate the important practical aspects about the S-cam type drum brakes. This is a side view of the typical truck's front axle. Now I am rotating a wheel hub along with the brake drum. These bolts that supports the brake drum over the wheel hub. The brake drum is nowhere connected other than bolts. On over this, a wheel will be mounted and secured by the wheel nuts. First, let us remove the brake drum from the axle. It can be done by simply pulling it. Extreme care should be taken during removal of the brake drum because the weight of the brake drum would be around 25 kgs. And this is the wheel hub with 10 bolts. The wheel hub would typically be mounted on top of the two taper roller bearings in trucks. This is the inner portion of the brake drum. The brake drum is made up of cast iron to withstand heavy vibrations that happens during braking. Next, we are going to remove the wheel hub from the axle. Before that, we may need to remove the hub cover that is secured by these 6 bolts. After removing this hub cover, we can notice the hub is locked by a lock nut on the axle. Once again, on the safety side, the lock nut is locked with the help of a safety pin. Now the safety pin is being removed. After removing the safety pin, the nut is unscrewed from the axle and it is pulled gently. The lock plate is taken out. This is one of the taper roller bearing that supports the wheel hub on the axle. After removing the bearing, the hub is removed. Now we can see the brake assembly. Let us see the components of the brake system. This is the S-cam shaft. You can see the profile of the camshaft, and these are the brake shoe rollers that supports the shoe, and this is your main return spring, and this is the auxiliary spring on the pivot end. You have got two auxiliary springs on front and back, and these are the pivot rollers, and this is a wheel speed sensor for ABS functionality to measure the wheel speed. It is the taper roller bearing that supports the hub on the axle, and this is your brake lining material riveted on the brake shoe. These are the brake shoe, and as you see, the rollers are kept on the groove of the brake shoes. Now let us dismantle the brake system. For that, we may need to remove the auxiliary springs that has been given front and back side of the system. These auxiliary springs help the brake shoes to come back quickly on the pivot end. These are the two auxiliary springs that has been removed from the brake system. These are the two rollers that supports the brake shoe on the pivot end. I use a simple lever to remove the rollers, pivot rollers. These rollers helping the brake shoes to be pivoted on the axle. Similarly, the rollers on the S-cam side also being removed against the tension of the main shoe return spring. These rollers would be somewhat bigger than the pivot rollers in size. After removing the rollers, both the brake shoes are removed from the axle. As you see, the main shoe return spring is hinged on both of the shoes. This is the back plate that prevents the dust particle enter into the system, and this is the wheel speed sensor for ABS functionality. This is connected with the ECU of the ABS. and these are the housing wherein which the pivot rollers are supported. As you see, the rollers are free to move inside the bore. Similarly, the rollers nicely fitting on the cavities of the S-cam shaft. Whenever the S-cam shaft rotates on its axis, it's freely transmitting the rotative motion to the brake shoe. Now we are going to see how the brake chamber pushrod motion induces the rotation on the S-cam shaft. As I move the brake chamber pushrod, you would see the S-cam shaft is rotating on its own axis. Now I am disconnecting the slack adjuster from the brake chamber. Since the S-cam shaft is mechanically connected to the slack adjuster, you can notice that it's rotating along with the S-cam shaft. This is a slack adjuster. The top end of the slack adjuster would be mounted on the brake chamber pushrod. The slack adjuster is secured with the help of circlip over the S-cam shaft that can be removed with the help of a circlip plier. And remove the washers. Now the slack adjuster is being removed from the S-cam shaft. You can see the splines on the slack adjuster that would be mounted over the S-cam shaft. Now these are the splines of the S-cam shaft. The splined shaft and the S-cam profile are welded together to form a S-cam shaft. Let us see the components of the brake system. This is the brake shoe without friction material. Next to the shoe you can find the split lining material. These are the brass rivets, cam rollers, pivot roller, brake shoe main return spring with the offset, and auxiliary springs. Let us see the construction of the brake shoe. This is a typical brake shoe without friction material. On either end of the brake shoe you would find one cam roller and one pivot roller is fitted, and middle of the brake shoe main return spring is hooked on the hinges. On a typical brake shoe you would find two pieces of friction material. This is the half of the friction material. These are the holes in which the rivet will be inserted. These are the metallic rivets. On a light duty application you would find the friction material would be bonded on the brake shoe. In case of heavy commercial application linings, the friction lining will be riveted to increase the strength of the bonding. So as I insert the rivets, you would notice it is popping out below the brake shoe. So after inserting the rivets, with the suitable punch, the rivet has to be flattened such that it lock the friction material in the lining. On the lining you can find a wear indicator beyond which the lining should not be used. This is the cut mark, failing which leads to major brake failure. This is the thickness in which you cannot cross during usage. Let us look at the construction of the S-cam shaft. This end is known as splined shaft. The other end is known as S-cam profile. These two portions are welded together to form a S-cam shaft. And this is your slack adjuster. The slack adjuster have got splines similar to the splines of S-cam shaft. The slack adjuster would be installed on the S-cam shaft like this. So whenever the slack adjuster moves like this, the S-cam shaft rotates on its axis. This is the front brake chamber, and yoke of the front brake chamber will be connected to the top end of the slack adjuster. On the spline of the slack adjuster, I have made a mark on a particular spline. It will help you to notice whenever I adjust the adjusting nut on a slack adjuster, it helps to rotate the S camshaft for some degrees. Inside the slack adjuster, there is a worm on wheel mechanism to perform this action. As you see, as I turn the nut, the spline is rotating on its axis. That means the S camshaft is twisting, and the clearance between the brake lining and the drum is adjusted. I am going to install the S camshaft on its bore. After insertion, the S camshaft has to be moved freely on the bore. Now I am going to put the oil seal, because the S camshaft will be lubricated with grease. In order to prevent any leakage, the oil seal should be fitted. Now I am going to fit the slack adjuster. During fitment of the slack adjuster, you should make sure that the S camshaft position must be like this. At any cost, the shaft position should not be like this. So place the shaft in the correct position and insert the slack adjuster on the splines of the S camshaft. Then make sure the slack adjuster moving freely. Then secure the slack adjuster with the circlip on the S camshaft. Finally, check once again everything goes smoothly. After the fitment of the slack adjuster, the yoke is fitted on the push rod of the brake chamber. The yoke is a simple coupler that connects the slack adjuster top end with the push rod of the brake chamber. This is the wheel hub assembly. A toothed wheel ring is inserted on the outer periphery of the hub. This wheel ring has got a master tooth. Whenever the master tooth crosses the wheel speed sensor, it interprets as 1 revolution in the given time. Then this information would be passed to ECU of the ABS. Let us assemble the brake shoe on the axle. This is the half of the brake shoe. This is the hinge where the spring is getting hooked. This side must face towards the S cam side, and place the brake shoe gently. This is the spring. It comes with an offset. This offset must face towards the S cam. This ensures the spring does not rub against the rotating hub during the operation. And take the other half of the spring on the given hinge. Gently hook the main spring properly. Then place the brake shoe below the S cam. Now we fit the pivot rollers on the respective boards. During assembly, make sure that the pivot rollers are free on the respective boards, otherwise it will lead to improper function of the brakes. And gently place the other arm. Before assembling the auxiliary springs, make sure that the two pivot rollers and the main spring are sitting in the respective places properly. This is one spring, and put it on the hole provided on the brake shoe. On the other end, put it with the help of a screwdriver. After insertion, make sure that the spring is sitting properly on the respective holes. In the same way, the second auxiliary spring will be inserted on the holes provided on top and bottom of the brake shoes. Let us put the cam rollers on the respective cavities. This is a cam roller. Now we are going to put this roller on the bottom of the shoe. Similarly, the second roller now is fitted on the top side. During fitment, extreme care should be taken, because now we are working against the heavy spring tension. Now you can notice that the cam profile and the rollers are not sitting properly. It can be adjusted by adjusting the slack adjuster mechanism. Kindly notice, as I adjust the adjusting mechanism, the cam profile is twisting on its axis and allow the rollers to sit it properly on the profile of the cam. Now you can see the profile and the rollers are sitting nicely. Let us put the hub in its place. Kindly note, we have not removed the inner taper roller bearing from its place. Now I am going to put the second taper roller bearing. And a lock plate is placed. This has got a slot to prevent any rotation during operation. Now the entire hub assembly is locked with the lock nut. I am not going to tighten anything with one simply hand tight. Now the nut is again secured with the help of a lock pin. Then the lock pin has to be locked properly. Now we can place the hub cover in its place with the help of 6 bolts. After assembly, make sure the hub is rotating freely on its axis. After this step, I am going to demonstrate how the brake chamber push rod pushes the slack adjuster and the brake is getting applied on a real vehicle. After the fitment of the hub, the brake drum is assembled on top of the wheel hub. The wheel hub have got 10 bolts. The holes on the brake drum has to be matched properly to insert it. In a real vehicle, after this step, a tire will be mounted on top of the brake drum and secured by the wheel nuts. By here, I am going to put the wheel nut as it is. Once the brake drum is secured properly, the gap between the friction material and the brake drum has to be adjusted to the level of 0.5 mm or 0.02 inches.